we've already introduced fractions, and the next thing we'll do is look at how to multiply fractions together. Yeah, we saw how to use rectangles to represent a fraction. For example, here 1/3. So yeah, think of the whole rectangle as 1, representing 1. And then if you divide it into, say, 3 equal pieces and shade in one of those pieces, that represents 1/3. Yeah, like if you wanted 1/3 of a chocolate bar, same thing, divide it into 3 equal pieces and then take one piece. And how about this? So instead of 1/3 of 1, how about thinking about what is 1/3 of 1/2? And so this time we're starting with 1/2. Okay, so like you have half of the chocolate bar, and then we want to get 1/3 of that. Okay, so we're dividing the 1/2 we started with into 3 equal pieces and taking one of those. So this piece here, so this is 1/3 of 1/2. But how much is this out of the whole rectangle? Well, you can see if you divide the other half into 3 as well, so now we get 6 equal pieces, and we have just one of those. So what I'm trying to say is, yeah, so 1/3 of 1/2 is 1/6. Okay, so if you only had half of the chocolate bar and you wanted to get 1/3 of that, so divide the half into 3 equal pieces. Yeah, then each piece is just 1/6 of the original chocolate bar. Yeah, maybe a clearer way to see that is like this. Okay, so we have the whole rectangle. Divide it into 2 pieces. So this is 1/2 of the rectangle. And then, just like before, divide that 1/2 into 3 equal pieces. But we can just continue the lines. So now we see it. Yeah, this 1/3 of 1/2, it's definitely 1/6 of the whole thing. And yeah, in the book we can see more examples. So here, yeah, they're looking at 3/4 of 2/3. Okay, so starting with 2/3. Okay, then we want 3/4 of this. So you can divide this piece into 4 supposed to be equal pieces and take take 3 of them. All right. So this is 3/4 of 2/3. And again, yeah, if you continue the lines like this, yeah, we've really broken the rectangle into 12 equal pieces, and we're interested in 6 of those 12. All right, so you can also see it here. Okay, so 3/4 of 2/3 is 6/12. Yeah, 1/2 of 1/3. So this is, yeah, we looked at 1/3 of 1/2. This is 1/2 of 1/3. So here's 1/3. Take half of it. Again, you're getting 1/6. Okay, so 1/2 of 1/3 is equal to 1/3 of 1/2. So yeah, so this, what we're doing here is really multiplication. So this this word of here, so taking a part of a part, that's interpreted as multiplication. Okay, so this 1/3 of 1/2 is 1/6. So we can write the equation 1/3 times 1/2 is equal to 1/6. Yeah, so any time you see of, the word of, yeah, it always means multiplication. And we can also see, so instead of drawing rectangles, there's an easier way to get the answer. So we really are multiplying. So if you multiply the tops together, so 1 times 1 is 1, and multiply the bottoms together, 3 times 2 is 6. Yeah, we're using a dot here for multiplication. You could use an X or use parentheses like this. All right, so the bottom line is there's a simple way to multiply 2 fractions together. So in general, if you have the fraction a over b times the fraction c over d, then that's equal to a times c over b times d. And yeah, you can see we're just multiplying straight across. Yeah, call it straight multiplying. Okay, the 2 numerators multiply to give you the new numerator. The 2 denominators multiply to give you the new denominator. And a very common mistake is to cross multiply. Okay, so yeah, it doesn't work like that. So the way to multiply 2 fractions is you always just multiply straight across. Okay, so I don't know why cross multiplying is so popular, but we'll see that it's a completely different idea. It's when we're solving proportions, we'll cross multiply. It's not used for multiplying fractions. So don't do that. Just remember so it's easy to remember. You just multiply straight across. Okay, just to see that example again here, 3/4 of 2/3. Okay, we get a complicated picture with rectangles shaded in, but it's really much simpler. It's just multiply the two tops together. 3 times 2 is 6. Multiply the two bottoms together. 4 times 3 is 12. All right, so that's what we're doing. Example 1, find 1/10 of 1/5. It's like a word problem, but again, remember of means you're multiplying. Here's 1/10 of or times 1/5. Multiply the tops, you get 1. Multiply the bottoms, you get 50. So that's the answer, 1 over 50. And yeah, I sometimes see people writing that that's equal to 50. No, so 1 times 50 would be 50, but this is 1 divided by 50. It's 1/50th, so it's just a very small part of a rectangle. So yeah, make sure you don't make that mistake. So you just leave it 1 over 50. All right, so multiplying fractions, yeah, you're just multiplying straight across. You don't need to get any common denominators, anything like that. It's much easier. Just multiply like this. Another example, compute 5/7 times 6/11. All right, so that's 5 times 6 is 30. 7 times 11 is 77. Any other tricks we need? Yeah, so here we're multiplying 5/7 by a whole number, 10. So how does that work? Is it 50 over 70? No, so just remember that any whole number, you can make it into a fraction. Just put it over 1. Okay, so the trick here is just to remember this idea. So this is really 10 over 1. So now it's 5 times 10, and we have a 1 on the bottom, so 7 times 1. So the answer is 50 over 7. Okay, so that's the way you handle whole numbers if you want to think of them as fractions. Okay, how about three fractions if we want to multiply them? Well, yeah, you can just use the order of operations. So start on the left. 1/2 times 3/4 is 3 over 8. Okay, so this is 3 over 8. Then multiply by 5/8. We get 15 over, 8 times 8 is 64. And in fact, yeah, so maybe an easier way to do that is, you can see it's just all the numerators are getting multiplied, so it's just 1 times 3 times 5 is 15, and 2 times 4 times 8 is 64. All right, so yeah, when you're multiplying a bunch of fractions together, if there are no other operations, if you're just multiplying, then again, straight multiply all the tops and multiply all the bottoms. Okay, so yeah, it couldn't be much easier. Just remember what to do. Okay, here we have the power. So how do you handle powers of a fraction? Well, just remember what powers mean. We're multiplying 4 over 3 by itself 3 times. The power is 3 here. Okay, so if you write this out, it's just 4 over 3 times 4 over 3 times 4 over 3. And so straight multiply 4 times 4 times 4 is, well, 4 times 4 is 16. 16 times 4 is 64. And 3 times 3 is 9. Times 3 is 27. Okay, yes, if so it's not 3 on the bottom. Yeah, you have to multiply the bottoms. So here, it's really 4 cubed divided by 3 cubed. Okay, so yeah, any powers like this, just write out what it really means and then do the multiplication. Okay, so in the book, okay, so here's our rule again for multiplying 2 fractions. So just multiply straight across. 3/8 times 5/7 is, 3 times 5 is 15. 8 times 7 on the bottom, that's 56. This example, what is 2/3 of 5? Okay, so it's 2/3 of, again, means multiply. So it's 2/3 times 5. And then that trick again, 5 is 5 over 1. So we get 10 over 3. Okay, here's a little word problem. 1/3 of a 12-member jury are women. How many women are on the jury? All right, so we need to find 1/3 of 12. So that's 1/3 times 12 over 1. So 1 times 12 is 12. 3 times 1 is 3. So we're getting 12/3. And of course, yeah, just remember this means 12 divided by 3. So that simplifies to 4. All right, so 4 women on this jury. 1/3 of 12 is 4. All right. Some mistakes to avoid. Yes, so going back to this 3/8 times 5/8. Okay, the correct answer, yep. Multiplying straight across, 3 times 5 is 15, 8 times 8 is 64. So yes to that answer. What can go wrong? Well, yeah, here I've done the top correctly. 3 times 5 is 15, but I've just kept the 8 on the bottom. So this is not correct. Yeah, you have to multiply. So 8 times 8, it should be 64. Okay, if you're adding fractions, then you keep the same denominator, so maybe that confuses people, but yeah, multiplying, it's everything has to get multiplied. And yeah, here, yeah, you can see where the numbers are coming from. Yeah, here I've used the wrong operation, so I've used addition instead of multiplication. So yeah, 3 plus 5 is 8. 8 plus 8 is 16. But we're supposed to be multiplying, so that's just a basic mistake that maybe beginners make, just using the wrong operation. So when you're multiplying fractions, you have to use multiplication. All right, so 3 times 5 is 15, 8 times 8 is 64. So yes, really the easiest thing you can do with two fractions is multiply them. We'll see that the other operations are a bit more complicated. Okay, but before we get to that, let's look at this idea, equivalent fractions. Okay, let's see an example. Let's compare these two fractions, 1/3 and 4/12. Okay, so we saw 1/3 earlier. It's this is the whole rectangle, and take 1/3, divide it into 3, take one piece. Here's 4/12 of the same rectangle. So I'm dividing it into 12 equal pieces and taking 4 of them. All right, and I tried to draw this accurately. So yeah, so you can see that really this is the same amount of shading. This looks slightly bigger, but they're supposed to be the same. So I'm saying if you get 1/3 of a chocolate bar, that's the same as 4/12 of a chocolate bar. Same amount of chocolate. Okay, so can we really check that they're the same? Just to remind ourselves, yeah, this is the key idea we're using all the time. So remember, A over B times C over D is equal to AC over BD. So just keep this in mind. And the other thing we need to remember, yeah, if you have a fraction A over A, for example, 4 over 4, that's always equal to 1. So A divided by A is equal to 1. Okay, so how do we show that 4/12 is equal to 1/3? Well, we could start with the 4/12 and kind of factor the top and the bottom a bit. So we have 4 is equal to 4 times 1. 12 is equal to 4 times 3. So we have a matching 4 here. Okay, so from our box, that's equal to 4 over 4 times 1 over 3. 4 over 4 is 1. And if you multiply anything by 1, you just get the same thing. So that's 1/3. All right, so hope you followed that. So we'll see this in a minute. So really, it's called canceling. So we cancel these 4s. All right, so 4/12 is equal to 1/3. And yeah, so even though they look different, they're kind of different looking fractions, but we say they're equivalent if they represent the same number. Okay, so it's exactly the same amount of shading. So fractions that look different but are really equal, we call those equal fractions or equivalent fractions. All right, so that's what this section's about. The next example show that 6/10 and 3/5 are equivalent fractions. Okay, so can we use the same kind of argument? So here you could start with the smaller number, or the fraction with the smaller numbers. So 3/5 is equal to 3/5 times 1. And how do we get, you can see that if you multiply 3 by 2, you get 6. If you multiply 5 by 2, you get 10. So we can use this, write 1 as 2 over 2. And so then we see it's 6/10. So 3/5 is equal to 6/10, so they're equivalent fractions. Okay, so we kind of went in the other direction, but it's the same logic. It's just, if you multiply anything by 1, it stays the same, but we can make 1 look different using this idea. So here 2 over 2 is equal to 1. In general, A over A or C over C is equal to 1 in general for any integer C, well, any positive integer C. Okay, so we have this, the fundamental property of fractions. A over B, the fraction A over B is equal to A times C over B times C. Okay, so this, again, it just follows because really, if you separate this out as A over B times C over C, C over C is just 1. So, so I hope you can see why this is true. Okay, so this is an important formula we'll be using. So if you go in this direction, so if you start with a fraction A over B, you can make it kind of more complicated. You can write an equivalent fraction with bigger numbers by multiplying the top and bottom by the same number. It could be any number. And we'll also see, if you go in this direction, you can make a fraction look simpler by really canceling. If you have the same number multiplying the top and the bottom, then you can cancel that number and get this simpler fraction. Okay, so we'll need this idea going in both directions. Okay, so going from left to right, for example, starting with 1/4 and taking C equal to 5. Okay, so putting in 1 over 4 is equal to 1 times 5 over 4 times 5. We see that 1/4 is equal to 5/20. Or we could pick a different number. So instead of 5, we could take 13. Okay, so this, just to emphasize, the C could be any number. What happens if we take 13? So then you can make 1/4 look like 13 over 52. Okay, so we've certainly made it look more complicated, but if you draw these two fractions as rectangles, they'll have exactly the same amount of shading. If we take C equal to 100, then we get 100 over 400. Or take C equal to 6, we get 6 over 24. Okay, so by taking those 4 different C's, we've found 4 fractions that are equivalent to 1/4. Okay, so these fractions, they're all equivalent to 1/4. They're all equal to 1/4. but they all look different. Okay. And yes, so there's how many fractions are equivalent to 1/4? Well, infinitely many. You can take c to be any positive integer. Okay, so you can certainly always make a fraction look more complicated, write it with bigger numbers. Will we ever need to do that? Yes, so when we're adding fractions, we're going to need this idea. Yeah, sometimes you need to have a bigger denominator. Okay, but often we also want to make fractions simpler. Okay, so now going from right to left, so making a fraction simpler. Example 7, simplify 13 over 52. Okay, we saw this already, but let's pretend we didn't know what to do, or didn't know that it was equal to 1/4. So what we're looking for, we want an equivalent fraction with numbers as small as possible. Okay, and so we already know that 13 over 52, it's really 1 times 13 over 4 times 13. So that's equal to 1/4. And here you can't simplify this. There's no way to get these numbers any smaller. And what we're doing, this is this important idea of canceling. Okay, so 13 over 52, if we write it like this, then we can see that this 13 cancels with this 13. And we get the simplified fraction 1/4. And yeah, nice way to write it. If you see a common factor in the top and the bottom, divide by that common factor. So 13 divided by 13 is 1. 52 divided by 13 is 4. Yeah, so this is the best way to write it. Yeah, don't write this. Yeah, this is different. This is not true. And again, going back to our box. So this is the key idea we're using. Let's use 2 colors. So if you have a situation like this again with a common factor c multiplying the top and the bottom, then you can cancel those c's. So if you divide the top by c, divide the bottom by c, you get this simplified version. Okay, and the key thing is you have to make sure you're doing the same thing to the top and the bottom to get an equivalent fraction. All right, let's try that on this fraction, 15 over 35. So we want to simplify this as much as possible. Okay, we want to find an equivalent fraction with smaller numbers. Okay, we're looking for something to cancel. We're looking for a common factor in the top and the bottom. And yeah, you can see that 5. And so 15 has 5 as a factor. So 5 divides 15. 5 also divides 35. Okay, so we can cancel 5s. Okay, so divide by 5 on the top, we get 3. Divide by 5 on the bottom, yeah, 5 goes into 35 7 times. All right, so we've simplified it a bit. Maybe we can simplify some more. Well, yeah, these two numbers don't simplify into anything smaller, so yeah, so that's the end of the row. That's the best we can do. So the answer is 3/7. Okay, so we cancel 5s to get 3/7. And since that's the best you can do here, that's called lowest terms. Okay, so if you've canceled everything possible, nothing left to cancel, then the fraction is in lowest terms. Okay, so 15 over 35, that's not in lowest terms, but here it is simplified. Okay, here's that fundamental property again that we keep using. Okay, how about this example? Can we simplify 18 over 24? So the trick here is to see that there's a common factor of 6. So yeah, so 18 is 3 times 6. 24 is 4 times 6. So we can cancel those 6's, and we're left with 3/4. All right, that's the best you can do. So in lowest terms, 18 over 24 is equal to 3/4. Okay, how about this one? 28 over 70. So yeah, we can do this in 2 steps. So for example, yeah, if you notice that 7 is a common factor in the top and the bottom. So if you cancel 7, so 28 divided by 7 is 4. 70 divided by 7 is 10. Okay, so we've simplified 28/70ths. But is it in lowest terms? No, not quite. There's still a common factor 2. So if we cancel those 2's, so 4 divided by 2 is 2. 10 divided by 2 is 5. And now we've got it into lowest terms. There's nothing else. Yeah, I'll talk about prime numbers next time, but yeah, there are no smaller factors here, so that's the answer. And another example here, more canceling. Yeah, let's do one more. How about reduce the fraction 15 over 3 to lowest terms? Okay, so here you can see there's a common factor 3. Okay, so 15 divided by 3 is 5. 3 divided by 3 is 1. So we've simplified it to 5 over 1. And yeah, don't leave it like that. It looks a bit funny. Any number over 1, just write that as a whole number. So the answer here is 5. All right, so that's that section.